Today's lesson, 2.4, is going to be about the properties of algebra. So our objective will be to identify the properties of addition and multiplication, and then we're going to use these a little bit later on, not in today's lesson. We're just going to identify them today. The first one would be commutative property. We have a commutative property of addition, shown on the left, and a commutative property of multiplication, shown on the right. And what this means is that the order in which we add or multiply does not matter. So we can move things around, and you can see some variable examples, a plus b equals b plus a, some multiplication examples, and also examples with numbers. So I'll give you some time to copy this down and the examples with it. The next property we're going to look at is the associative properties of addition and multiplication. So for any numbers a, b, and c, for both, you can see that in the first example for addition, a plus b plus c, the a and b are grouped together. And on the right-hand side of the equal sign, the b and c. So associative, if you think of the root word to associate, it's who it's grouped with. So the grouping symbols are there, and it's changed its association with the numbers. So the way that it's grouped won't change the sum for addition, and it won't change the product. However, notice that the actual variables or the numbers didn't move. The parentheses are what moved. And you can tell inside the parentheses there's different variables or different numbers, and that's how you know it's associative. Sometimes you're going to have some associative and commutative looking things going on at the same time. You'll have parentheses even if it's commutative. So you're going to have to take some time and think about what's happening. One thing I like to do is if I look at the left-hand side of the example and I notice that the numbers don't change order. So for instance, for the addition, it is 5 plus 3 plus 1, and then on the right-hand side it is 5 plus 3 plus 1. So since the order didn't change of the number, then it's not commutative. And then I look at the grouping symbols to see that they changed association. For our identity properties, for addition, it's adding 0. It won't change the sum. And for multiplication, it's multiplying by 1. Won't change the product. And finally, the multiplicative property of 0. Anything times 0 is 0 for any number. So let's try a few of these. If we're looking at the first one, I look at the order first. So I have 6 plus 2 plus 4, and then 6 plus 2 plus 4. Since the order didn't change, it's probably not commutative. And I have grouping symbols, so I look to see what's grouped together. I have 2 plus 4 on the left and 6 plus 2 on the right, so it has changed association. And notice that it is all addition signs, so it has to be associative of addition. And a lot of times you can leave off the word property, associative of addition. But putting which operation it is very important, because we have associative of addition, we have associative of multiplication. Which one did you mean? Looking at number 2, 76 times 13 is equal to 13 times 76. Since the order of the number changed, they kind of commuted around the multiplication sign, I will call this commutative of multiplication. Again, real important to have this last part, commutative of multiplication. Okay, 0 plus 36 is equal to 36. It's a 0, but there's an addition sign, which tells me that this is the identity of addition. Okay, just because you see 0, don't think of the multiplication of 0 property. In example 4, or number 4, xy with parentheses times 0. Just because I see grouping symbols does not make it associative because I'm multiplying by 0. It is the multiplicative property of 0. And that's important to have all of that written as well. Final two examples. This is where you really have to show that you know your stuff because there is multiplication and addition in this example, in both of these examples actually. So the first thing I'm going to do is look at the order. I said that, if it's commutative, it will change order. And I see grouping symbols, so right away I want to think associative. However, if I look at what's in the grouping symbols, x plus 3, it's x plus 3 on both sides. So I can rule out the associative because it's grouped with the same two terms. But in the left, it's 2 times the sum, x plus 3, and on the right, it's the sum times 2. So what happened was that these two numbers, or these two expressions, switched places or commuted around a multiplication sign. It's supposed to be pointing to the multiplication sign. And so this would be commutative of multiplication. And when I look at 6, I have again the grouping symbols and addition and multiplication. So I look at the grouping symbols, and even though A is still grouped with B, right, that's going to tell me A and B are grouped together, that it's not associative because it didn't change who it was associating with. However, I have the parentheses with the A and the B times 7, then I have the parentheses times 7, but if I look at what happened, they have commuted around an addition sign. They changed places. So this becomes commutative of addition. So we're going to take a look now at several more examples in class, and then you should have enough information to be able to identify the properties of algebra.